joining us tonight. So I'm going to do the intro, and then I'm going to pass across to Danielle, and then we're going to have a Q&A at the end with Syed. Firstly, to do a bit of an intro and a bit of context. So on behalf of Jane Ohlmeyer, Director of the Trinity Long Room Hub and Extension Doc, I want to welcome you all here to Trinity College for the latest talk in what it means to be human. For those of you joining us here and online for the first time, what does it mean to be human in the 21st century is a cross-disciplinary lecture series launched in December 2018 as a collaboration between Accenture's Human Insights Lab and the Trinity Long Room Hub Arts and Humanities Research Institute. It's also great, I should say, to be here in the New Business School, so thanks for accommodating the event. This new series seeks to reflect on how we understand ourselves in the world and our place within it by bringing together academic and creative voices at Trinity to discuss the human experience of today and its future in the face of accelerated change brought about by artificial intelligence and technology. This is our penultimate talk in the series. Today we've looked at our journey from existence to extinction, the era of the mind, material culture, and our relationship with technology and the devices that know us best. So, tonight's highly anticipated talk will be delivered by physicist Danielle Bassett. Combining a strong background in physics with training and collaborations in neuroscience, Professor Bassett adapts mathematical approaches associated with the study of complex networks, such as computer social networks, to analyze interactions amongst neurons in different regions of the brain. Danielle received a BS from Pennsylvania State University and a certificate of postgraduate study, and a PhD from the University of Cambridge. She was a postdoctoral associate and a SAGE Junior Research Fellow at the University of California in Santa Barbara, before joining the faculty of the University of Pennsylvania. By the age of 32, Professor Bassett had been awarded the MacArthur Fellowship, prestigious acknowledgement of her exceptional achievement and creativity in her work on brain connectivity. A recent Science magazine article commented that Bassett routinely disregards disciplinary boundaries and follows her curiosity with abandon. In fact, her email signature lists no less than 5 departments that she's affiliated with in her position as J. Peter Skirkinich Professor with the University of Pennsylvania. These include the Department of Bioengineering, the Department of Physics and Astronomy, the Department of Electrical Systems and Engineering, the Department of Neurology, and the Department of Psychiatry. Professor Bassett will cross disciplinary boundaries again tonight when she talks to us about the curious human, integrating historical, philosophical, and psychological perspectives with techniques from applied mathematics and statistical physics. So before we get going, just a reminder, before we welcome Professor Bassett to speak, I would like to remind you that we'll be on Twitter using the hashtag #HubMatters and #BeingHuman and tagging @TLRHub. We're also live streaming tonight's discussion, and it will also be a podcast on the Trinity Long Room Hub website. We're delighted that following Professor Bassett's talk, Syed Ghazi from the Doc at Accenture, with an interest in complex systems, will curate a follow-up discussion with questions from the audience. So please welcome me in joining. Please join me in welcoming Danielle Bassett.
Thank you very much for the very kind introduction. I was told that I should turn the lights down. But it doesn't look like, wonderful. So today, the topic of my talk is the curious human. Can everybody hear me in the back if I stand close enough? Not really. I have quite a small voice. All right, I'll try this. Is that better? At the back, a little bit better? Yeah, I'll try to speak up. Okay. So I wanted to actually start with the human brain, and which is the topic of much of the work that I focus on in my daily life. And I'm really fascinated by this extremely intricate, beautiful pattern of interconnections that allows for information to pass from one side of the brain to another side of the brain, or from one functional portion of the brain to another functional portion of the brain. And what I'm most captivated by in this system is its ability to adapt, to change, and to learn, which I think makes us as humans much of what we actually are. And in fact, a lot of the work in my lab is currently focused on understanding this, the formal experiments that can be done to probe how humans learn and how we can teach them new information. So for example, in a recent study, this Tang et al. In 2019, we're teaching individuals about novel shapes and what the value of those novel shapes are. And so we're trying to push the boundary of understanding how humans can learn new information with these fairly simple, stylized laboratory experiments. And I don't want to belittle that work at all, but I also am kept up at night with the question of whether these highly stylized experiments really have anything to do with how humans really behave and learn. And so when I'm sort of sitting, alone at night thinking, I want to know, what is learning? Is learning what we're doing when we are teaching somebody inside of the scanner, or is learning something really quite different? And so in preparation for this lecture, I pulled out my 1939 Oxford English Dictionary and I looked up learn. And so in the OED, it is to get knowledge of subject or a skill in an art by experience, study, or teaching. And what I think is really interesting about this definition is that teaching, that portion that I actually use in the experiments and learning that I use in the lab every day, that is third in this list. The first two are study and experience, which really are much more individually motivated than the teaching portion. So just to be sure, I pulled out my 1971 edition as well and confirmed the order remains unchanged. All right, so that definition makes me think a little about this quote from Ralph Waldo Emerson, where he says, "Man thinking, him nature solicits with all her placid, all her monetary pictures, him the past instructs, him the future invites. Is not indeed every man a student, and do not all things exist for the student's behoof?" Now, we acquire knowledge not simply by formal teaching, but from everything around us, as this passage indicates. And that mode of acquiring is tightly interdigitated with the human mode of curiosity. Perhaps what I should really be studying as the more quintessential form of a human's capacity to learn is curiosity. Now, but here we've moved from one fundamental question to another. So one fundamental question is, what is learning? Now we've moved to a second fundamental question, which is, what is curiosity? Is this really any simpler or just as difficult? When I pronounce the term, several images may come to your mind. Perhaps when I pronounce the term curiosity, you think of the game, Trivial Pursuit. And then you may fall quickly into the terrible trivium from Phantom Tollbooth. Or perhaps when you think of the term curiosity, you think of a 2-year-old asking that unending string of questions that just keeps going and going and going and going. Or perhaps you think of the beautiful sight of hands raised in a classroom. Now, perhaps curiosity is the love of trivia, and perhaps curiosity is the asking of questions. But I think all of us, when we think about the individuals in our lives, can think about very curious individuals who really don't like trivia and really do not care to play Trivial Pursuit. We can also think about very curious children or very curious adults that don't verbalize many questions, perhaps because they're shy or quiet or otherwise rather thoughtful. So is it true that these common notions of curiosity really capture what the idea is? Now, perhaps when I pronounce the term curiosity, your mind went to this wonderful piece from Norman Rockwell, which paints a quite amusing picture, I think, of the faces of curiosity in social information. If you study all of them, it'll crack you up. Or perhaps your mind goes back another century to Australian artist Jane Sutherland's picturesque piece called Little Gossips, which paints a very different picture of curiosity for social information. Or perhaps your mind went back another 100 years to around 1750 to this British Museum's Tittle Tattle, or the several branches of gossiping, which offers a satire on women of the time, childbed, church, the market, public baths, the conduit, washing clothes in the river, the ale house, the bakehouse. These are all shown as opportunities for women to exchange gossip. Now, our feminist affront aside, this is an interesting depiction of the notions of curiosity of the time. Now, this quandary of how to actually define curiosity and its places and its actions is not a challenge that we, as humans in the 21st century, face newly. This is something that many individuals over the course of time have faced. Augustine, for example, suggests that curiosity is a lust to experience and find out. Aquinas suggests that curiosity is the desire to know. From Descartes, we have that curiosity is a desire to understand. And from John Locke, curiosity is an appetite after knowledge. William James, in 1899, curiosity is the impulse towards better cognition. John Dewey, in 1933, curiosity is an interest in problems provoked by the observation of things and the accumulation of material. Voss, in 1983, curiosity is a motivational prerequisite of exploratory behavior. Lowenstein, in 1994, curiosity is a feeling of deprivation produced by information gaps. And Nicole Kidd, in 2015, curiosity is a drive state for information. Now, all of these different definitions are all well and good, but number one, they are quite abstract. And number two, they differ from one another in rather meaningful ways. And from these differences, we can deduce that actually it's quite difficult to define what curiosity really means. But I want to suggest that perhaps there is an alternative approach to coming up with these simple, maybe parsimonious descriptions of curiosity that could shed greater light on the question of what curiosity is. So to answer that question, we've been collaborating with Professor Perry Zern. So he's a philosopher at American University outside of Washington, D.C., and what he did recently is to perform a historical philosophical examination of the word curiosity. Now what this means is that he goes through using words for curiosity from Greek, from Latin, from French, from German, and from English, and he traces the common notion of curiosity through the usage of these specific terms, watching how the usage changes and watching how the meaning can potentially change, either over one historical period or over several historical periods. In this particular case, he went back to millennia and tried to follow it all the way through. Now, from these data, he built a taxonomy of curiosity based on what he calls kinesthetic signatures, which means the actions or the movements of curiosity. And he refers to them as the busybody, the hunter, and the dancer. And we'll walk through each of them in turn. So the first style, the busybody. From Plutarch, a good example of this style, is from his On Curiosity, where he says, "And the busybody, shunning the country as something stale and uninteresting and undramatic, pushes into the bazaar and the marketplace and the harbors, asking, 'Is there any news?'" And this is the clear picture of the busybody in the center of the town, right? And then from much later, from Martin Heidegger, in his Being and Time, he suggests that curiosity can be well characterized by the not staying with what is needed, or distraction by new possibilities, or never dwelling anywhere. Now we can contrast that style of the busybody with the second style of the hunter. So here, again from Plutarch and again from his On Curiosity, we have the notion that if you have to be curious, don't turn aside and follow every scent, but keep your sense of smell pure and untainted for its proper task. From Friedrich Nietzsche, in Beyond Good and Evil in 1886, the man of curiosity is described as wishing he had a few hundred helpers and good, well-trained hounds that he could drive into the history of the human soul to round up his game. A very clear vision of a hunter. And from Jacques Derrida in 1997 in The Animal That Therefore I Am, to be curious is to track, to sniff, to trail, and to follow for some of the reasons for the so confident usage of words. So clearly, the hunter is curious, but curious in a very, very different way than the busybody is. Now the third style, the dancer, again from Nietzsche in his Gay Science in 1882, describing thinkers of the future. And that's actually what we're all here to be thinking about, right? Thinkers of the future. So here's his opinion of thinkers of the future. "We do not belong to those who have ideas only among books, when stimulated by books. It is our habit to think outdoors, walking, leaping, climbing, dancing, preferably on lonely mountains or near the sea, where even the trails become thoughtful. Our first questions about the value of a book, of a human being, or a musical composition are, can they walk? Even more, can they dance?" This is much more about large movements as we search for information. And from Michel Foucault in The Masked Philosopher, I can't help but dream about a kind of criticism that would try not to judge, but to bring an avoir, a book, a sentence, an idea to life. It would light fires, watch the grass grow, listen to the wind, and catch the sea foam in the breeze and scatter it. It would multiply not judgments, but signs of existence. It would summon them, drag them from their sleep. Perhaps it would invent them sometimes, all better. I'd like a criticism of scintillating leaps of the imagination. I dream of a new age of curiosity. Now, when I think of these three different styles of curiosity that philosopher Perry Zurn describes, what strikes me most as fundamentally a scientist is that I think they all differ in what they actually do with that information, and specifically what kind of connections are made between the pieces of information. So the busybody obviously gathers discrete units of information and kind of puts them in a bag for later, a little bit like this coin purse, right? None of the pieces of information at the town market necessarily need to be linked to one another. They don't need to be related to one another. This person just wants the independent units. This is a little bit more like the trivia. The hunter gathers those same discrete bits of information, but then densely connects them in an orderly way because they're tracking. They're linking idea and concept to the next idea and concept, linking them together in a concerted path toward something, right? So they must link them, a little bit like these coins are linked in the necklace. And the third, the dancer, gathers these discrete bits of information and then connects them in dense clumps separated by these large leaps. And so we have a very different architecture similar to that illustrated in this Tibetan coin sculpture. So perhaps, I think what this makes me think is that perhaps curiosity is not necessarily what we are curious about. So maybe it's not about trivia necessarily. And perhaps curiosity is not what physical actions we take. So maybe it's not the asking of questions or the raising of hands. But perhaps curiosity is how we build knowledge from the concepts and their relations with one another. And here I'm showing just a simple depiction of concepts as these little dots, and then relations between those concepts as these little lines. And so perhaps the busybody builds disconnected knowledge, the hunter builds orderly, targeted knowledge, and the dancer complements a local order with these long-range leaps into new conceptual spaces. Now that idea that perhaps curiosity is related to the notion of knowledge as a network, and begs the question of, is knowledge actually a network? Because if it isn't, then this notion of curiosity really makes no sense at all. And actually, the notion that knowledge is a network is something that has been alluded to by several great minds in both the sciences and the humanities over the last several decades. And I particularly like these two passages. The first is from Henri Poincaré, so from the science side. He was a mathematician and physicist. In 1905, in his Science and Hypothesis, he says that aim of science is not things themselves, as the dogmatists in their simplicity imagine, but the relations among things. Outside these relations, there is no reality knowable. And then John Dewey, in his 1916 Democracy and Education, really hits it on the head when he says, knowledge is a perception of those connections of an object which determine its applicability in a given situation. Thus, we get at a new event indirectly, instead of immediately, by invention, ingenuity, resourcefulness. And ideally, perfect knowledge would represent such a network of interconnections that any past experience would offer a point of advantage from which to get at the problems presented in a new experience. So then perhaps curiosity can be usefully defined as knowledge network building. This notion is also actually alluded to in Dewey's work, the same Democracy and Education, where he says curiosity is not an accidental, isolated possession. It is a necessary consequence of the fact that an experience is a moving, changing thing involving all kinds of connections with other things. Curiosity is but the tendency to make these conditions perceptible. So now we have arrived at this general notion of curiosity as knowledge network building, and it's been directly informed by a historico-philosophical investigation across multiple millennia, across cultures, languages, and timescales. And now what I want to do as a scientist is to test it with the tools of modern science, to say, is this characterization that we've observed or that I should say Professor Perry Zern has observed from primary literature over the past 2 millennia, is that something that we can quantify, that we can measure, that we can probe scientifically in the minds of today. So let us posit that as humans, as we move from book to book, or as scientists, as we move from paper to paper, or as citizens, as we move from web page to web page, we are building knowledge networks. What sorts of networks do we build? What do they look like? What is their architecture? Do we have different preferences in how we build these networks? Do each of us have slightly different preferences? These questions amount to asking how we are curious and whether we are curious differently from one another. Now, the work that I'll describe over the next few minutes was actually led by Dr. David Lydon-Staley, who's a scientist and psychologist in my laboratory, and he actually was born in Galway, and he's a very proud Irishman. He went to Trinity for his undergraduate degree and is now over at the University of Pennsylvania, so I'm particularly excited to be able to present his work to you here as his home community. All right, so David began this study by inviting 159 human participants to browse Wikipedia for 20 minutes a day for 21 days. So each of the participants signed a consent form that allowed us to download software onto their computer that would track which Wikipedia pages they were reading over that 20-minute period and in what order. No other information was tracked from any of their computers. So this was just for that particular session each day. So across the entire study, 18,654 pages were visited. So it's a really incredibly rich data set of human information searching. Each participant searched for about 5 hours over the course of those 21 days. And from that data, we built networks, so for each individual. Every Wikipedia page is a node inside of the network, and then 2 Wikipedia pages are linked together by similarity in their content. And we used some tools from natural language processing that allows us to assess similarity in content between 2 Wikipedia pages. So then what we can do is that we can try to understand whether a single human is walking among concepts that are very related to each other or walking among concepts that are very not related to one another. And what you see here on the left-hand side of this colored bar graph over here is someone who has relatively low similarity between the pages that they traversed among. So they're actually jumping very far between pages conceptually. Whereas on the very right-hand side, you can see someone that has higher levels of similarity, so more of the light blue here, and that means that they are walking among pages that are very similar in content compared to the other person. And so these are just 3 different individuals to show you that you can get very different characteristic browsing patterns from people in the study. Okay, so now we are ready to assess the network structure of each individual and their Wikipedia browsing patterns. Well, the way that we do that is that we use tools from network science, which is a rather new and emerging scientific discipline that studies the architecture, dynamics, design, and control of complex interconnected systems. What's really nice about it is that it provides a toolbox that includes analytical pipelines, but also statistical metrics that help us to quantify very particular types of patterns. So the 2 schematics that I'm showing you here are illustrations of types of statistics that you can quantify from a network architecture. So on the right-hand side, you see the notion of clustering, which is basically a reflection of the likelihood that the neighbors of a single node are connected to one another. If the neighbors of a node are connected to each other, then actually the 3 form a triangle together. So the clustering coefficient actually reflects sort of the proportion of triangles inside of the network. So a network that has a very high proportion of triangles is one that very densely traverses the structure, and people move from one concept to another related concept to another one that triangulates between them. Okay? Now on the left-hand side, you see the notion of path length. So a path length quantifies how many edges or how many of these links need to be traversed in order to get from one part of the network to another part of the network. If that number is very low, it means that most of the nodes are connected to one another. It's a very dense packing. And if that number is very long, it's more like a string. So the longest path length that you would find is where you have one node here that connects to another and another this way all the way out to the wall. So you would have very many number of hops to go through in order to get from one side to another. Okay? So high path length is this more stringy notion. Low path length is this dense, more circular notion. Okay. So now we can go into the data that we have from individuals, and we can ask specifically, how do curious humans in action build knowledge networks? Now there are three very common types of networks that people often study in the complex systems literature, and they're shown over here on the left-hand side. So a regular lattice is one that is very heavily ordered. A random graph is exactly what it sounds like. The edges are placed at random, and then a small world structure is in between. Now, small worldness, I don't know, have other people heard of the 6 degrees of Kevin Bacon? A few of you? Okay. So the notion there is, and other people may have even heard of the small world effect itself, which is basically that you can, for particular kinds of network architectures, you can get from any one person to any other person fairly quickly in very few hops. That means that there's a very short path length in that system. So that's a technical description behind there. So the small world structure here, what you see is that you have lots of local clustering, but you have a few longer distance connections that allow you to traverse not just from one node to its neighbors, but from one node to something farther away along the circle. Now, what we find is that human participants, on average, tend to create very small world networks through their Wikipedia browsing patterns. And that's illustrated here on the bottom left, where you have the small world propensity. Here's all of the data from the 149 individuals. And what you can see is that these values pass the threshold of 0.50, which indicates that they are very strongly small world. Now, intuitively, what does that mean? Intuitively, what that suggests is that humans are exploiting information in neighboring concepts, while also ensuring that the chosen concept space is efficiently traversed, in some way possibly optimally navigating the information content space around one. So it's this trade-off between going among common concepts and then taking some longer distance steps. All right, so now that we understand a little bit about the networks that humans build, we can specifically search for the types of curiosity that Harrington proposes in his historical philosophical taxonomy. So using these ecologically valid Wikipedia experiments, we can ask which sorts of networks would a hunter build? And which sorts of networks would a busybody build? Now, just to remind you, the hunter wishes that they had a few hundred helpers and good, well-trained hounds that they could drive into the history of the human soul to round up their game in a targeted search for information. So we could suggest, perhaps, that that type of search would create a different sort of network than the busybody, who will frisk about and rove about at random wherever they please. So specifically in the parlance of the two statistics that I described to you just now, we would hypothesize that a hunter is going to create networks that have relatively high clustering and relatively short path length. And conversely, we would hypothesize that a busybody would create a network structure that has relatively low clustering and high path length. So these translations allow us to basically operationalize the kinesthetic signatures of curiosity in the parlance of this emerging discipline of network science. Now, to link this a little bit more strongly to the notion of curiosity, we also ask the question of, is there a particular personality trait that we would link to this type of search? And we specifically thought of deprivation sensitivity. So deprivation sensitivity, someone who's high in deprivation sensitivity is someone who has a drive to eliminate the unknown as they encounter new information and recognize gaps in their knowledge. So therefore, individuals with very high deprivation sensitivity would be the hunters with high clustering coefficients. And individuals with low deprivation sensitivity are going to be the busybodies with relatively low clustering. All right, so here are our hypotheses. And we're going to go into the, I am a scientist after all, we're going to go into the data, we're going to ask, are those hypotheses borne out by the data? So here is on the your left-hand side, what you see is the average clustering coefficient. Every data point here is a person in a Wikipedia study. And here you have the deprivation sensitivity of each individual. And so what you see is a positive relationship here, which means those who are high in deprivation sensitivity, so the hunters, are ones that have high clustering coefficient. And individuals who are low in deprivation sensitivity, so more of the busybodies, have low clustering coefficient, consistent with the hypothesis. And on the right-hand side, you see related data, but now for the path length that I told you about. So here is the path length on the y-axis, and then on the x-axis is deprivation sensitivity. You see a negative correlation between these two, indicating that individuals with high deprivation sensitivity are the hunters with relatively low path length, and then those who are low in deprivation sensitivity have high path length, so reflective of being busybody. Okay, so that's what the data said, but kind of in words, what we find is that these individual differences in deprivation sensitivity lead to the creation of knowledge networks with very distinct architectures. So more simply, when we seek information, all of us seek it differently. And because we seek it differently, we create different networks of knowledge. And I think that that's really exciting, but I think it leaves open many, many important questions. So one particularly important question I have is, what happens when we go to learn a new field of study, and that network, the network of that new field of study, has a very different architecture than the one that we prefer. So for example, what if I am a busybody, and then I want to go learn something like linear algebra, which I teach at Penn, where all of the ideas are very, very tightly linked to all of the other ideas. Maybe I would find it difficult to learn that particular field because it's not in the structure that I prefer to learn. It's a hypothesis. It's an open question. Second, do humans preferentially create networks that we understand? Maybe the networks of knowledge, maybe knowledge itself has an architecture that is the way it is because that's the kind of architecture that we understand. So it's not a perfect busybody architecture, it's probably also not a perfect hunter architecture, and somewhere in between. And then that makes me ask, what about artificially made networks, or artificially made information, artificially made knowledge? What kind of architectures do they have? Do they match with the human expectations, or do they disobey the human expectations? Why? How? And then does knowledge evolve over time to more closely match human building preferences, or vice versa? Maybe, perhaps even more importantly, what happens in the mind when we learn networks? What is going on in the underlying neural circuitry? And this reminds me of this passage from Aristotle's Metaphysics where he says, mind thinks itself because it shares the nature of the object of thought, for it becomes an object of thought in coming into contact with and thinking about its objects, so that mind and object of thought are the same. So we experience this networked world, right? And then we build networks of knowledge derived from those experiences. And we do that using a network of physical wires along which electrical signals can pass, allowing for this efficient processing of information. Are each of these networks in these three different layers, are they mirrors of one another in some important way that allows for us to make these representations and these matches from world to mind? I think as we look to the future and consider how we can begin to answer these types of questions, I also want to look back at this particular study as an example of a fruitful approach. So we began with some hard questions. What is learning? What is curiosity? We were dissatisfied with existing definitions that were not embodied in the human form. We therefore turned to history and philosophy, to ancient and modern texts, to develop a more holistic approach to the study of curiosity. We talked about the work of philosopher Perry Zurn uncovering these main styles of curiosity and noted their differences in connectivity, which led us to postulate that curiosity can be fruitfully defined as knowledge network building. We then developed a scientific experiment, more ecologically valid scientific experiment than the ones we usually run in my lab, based on Wikipedia browsing, and then capitalized on recent advances in natural language processing and applied mathematics and network science to analyze that data and test the postulate. The work is basically what I hope comes across as a living reflection of my claim that science of the mind, a science of the mind that we really want, must account for the minds of today and those of yesteryear. And in fact, I think that by solely studying the brains and the societies and the cultures of today, we often fall victim of the ineffectuality of temporal primacy. So here is a human brain you see on your right-hand side, which exists today in all of its multicolored glory across all of us. However, by studying just this one part of space, we can find ourselves to an extremely narrow window into the workings of the human mind. If we can go outside of today, we are offered a rich window into the human mind that is located in literary work and in philosophical expositions across many different time periods. And all of that can now be quantified with emerging tools from natural language processing, from applied mathematics, from network science. And I think that this added dimension, going back in time, can allow us to supersede the constraints of temporal primacy and provide us with a much richer description of human thought. I really think that this discrepancy for my field, in the focus of the brain of today, while ignoring the mind of yesterday, calls for a concerted breakdown in the current barriers between the sciences and the humanities. And specifically, I think that we need a concerted commitment to enhance precision in our description of human thought that's not just about today. Enhance precision in the tasks that we construct to probe human thought. It's not just about what we observe today. And then also we need to inform our study of the brain with a quantitative study of historic use of natural language and historic topics of philosophical discourse. So in the words of a well-known Dubliner, I have the words already. What I am seeking is the perfect order of words in the sentence. You can see for yourself how many different ways they might be arranged. And I think that by understanding how the words are arranged and the meanings that they reflect in historic literary work and philosophical exposition, we can really fundamentally reshape the types of questions that I, as a neuroscientist, ask about the mind and its underlying neural circuits in a really profoundly new way, and expand our understanding and our ability to understand this quintessential complex system, which is human thought. With that, I'd like to acknowledge the team that was important in helping me think through a lot of the work that we've described here, and also these two main collaborators, Professor Carrie Zern, who's at the Department of Philosophy at American University, and Dr. David Leiden-Stanley, who led the Wikipedia study that I described to you. With that, I'd love to thank you for listening, and I guess we can move into the question period. Thank you.
Hello. Thank you. This was great. So I know that probably a lot of the audience has a lot of questions, so I'm going to move to you. But before we do, I'll be selfish and ask a more philosophical question. So you use the word knowledge networks, whereas most of these seem like information networks to me, and I don't know if that's a semantic thing. And I think in a similar thing, you use the word mind, and a lot of this, when we talk about like networks, we talk about like the neural networks in the brain. So is there a difference, or are you using the terms interchangeably?
That's a great question. There is a difference. I would not necessarily say that mind is the same thing as a neural network. What we want to understand is how mind comes from neural circuitry. So I think that neural circuitry is an important substrate for mind, but they are not synonymous. And understanding the relationship between them is one of the large challenges in neuroscience right now. In terms of information and knowledge, what I've described is particularly in the Wikipedia study, is an instantiation of knowledge in information present for a human. And I'm hoping, I think the underlying assumption is that that information is a reflection of knowledge. It may be an imperfect reflection. As a scientist, I believe most things are imperfect. But yes, those are really good questions. So I please be clear that I'm not suggesting that they are the same. However, I think there's a tighter link between information and knowledge than there is between mind and neural circuitry. At least we understand it a little better.
Correct, because especially when you talk about human thought is a function of essentially human memory, and that resides in the brain. We don't really know how it sort of works, and I mean there is another philosophical question of like, because thought is a process of memory, and memory is always of the past, can something new come out of the past? Can something new come out of the memory? But I suppose we could talk about that later. So, if you have questions, we have mics, or I'll run to you, I suppose.
Maybe if people want to try talking loudly,
yeah.
And then if we need to, we can bring you the mic. So we
Right,
only have
so
42 mics. It's still a new building.
I appreciate the open nature of the research, but the actual example you gave was completely unconvincing. The scatter diagram has a very low correlation. Couldn't you come up with a better example?
I think there's
There's very little correlation in there.
Yeah, I'm very used to studies of individual differences in humans where there is often a lot of scatter because there's a lot that's unexplained by the model. What I described to you is a simple model that captures sort of the first, you could maybe think about it as the first principal component of what's actually happening, but there's a lot more to it.
All right.
So you explained the types of curiosity. I just wanted to ask your personal preference. According to you, what is the right kind of curiosity a person should have? Should it be hunter or busybody? Because I recognize myself as a busybody because I just collect random information and I don't know where to go. But like according to you, what is the right approach or right curiosity to have?
Yeah, that's a great question. I actually don't think that there's necessarily a right. And in fact, when we've had some discussions about, even in the scientific practice of research, what is the type of curiosity that we see among scientists? And we often see a progression through all three types. So at the very beginning of a study, we may be more like busybodies, gathering a lot of disconnected information. We're not necessarily sure where it's going. When we start to understand a little bit more, we have much more of a targeted approach, so much more like the hunter. But then when we're trying to finish this study and understand how it relates to the rest of the literature that's published currently or to the future, then we become much more like the dancer. And so even in the process of scientific discovery, I think each of them is passed through in some order. And maybe for other disciplines, they're passed through in a different order. But yeah, I don't think any is preferred necessarily.
It would be interesting to sort of see how a lot of inventions came, like what sort of state they came from, because I guess a lot of major ones, like in medicine, Viagra, the penicillin, like microwave, the flying planes, a lot of them came from curiosity and accidents, and the ones who were very focused with all the resources sort of didn't come to the same conclusions. Yes, please.
How does your model, is it transferable? How does it work for bodily knowledges, somatic knowledges, those kinds of things? Because you said curiosity is how we build knowledge from concept, but there is a whole kind of set of bodily knowledges which seems to me to be non-conceptual and also doesn't fit the information paradigm.
Right.
So does your model, is it transferable to those kind of forms of somatic?
That's a great question, and it's honestly not something that I've thought a lot about. I think it's fascinating, but I would have to say I haven't thought carefully about how the model would translate to somatic knowledge. But I agree that there is curiosity in movement. The way that people move can have the same kinds of reflections of curiosity. And so in that very gross sense, yes. But how the specific model occurs, I would have to think about that more. It's a good idea.
Gentleman, Richard.
So I'm curious, you studied Wikipedia for this work, and I'm really curious if there's any bias in Wikipedia, because there's just a small number of people who are contributing actively to it, and I would guess they have a certain pattern of behavior that they follow, and would that pattern be useful for everyone in terms of the way they write the content of Wikipedia? Because I could imagine many people would have a hard time accessing it if it's very biased towards certain people.
That's a great question. I mean, my understanding was that it's actually written by a lot of people, not necessarily a few people, but I don't have a particular number to put to that intuition, so I would hold on until I gather my facts. But I think an interesting way maybe to address that scientifically to determine whether that could be a bias here is to take random samples of subsamples of Wikipedia and say, what is the architecture here after randomly determining the different writers, and then confirm that the architectures are similar, at least within the same domain. So I think that that's something that's empirically quantifiable, we can measure it. And that would be a good thing to do.
That would be interesting.
Yeah.
Yeah, that's very interesting. And a study has been done at Cornell, and Simon Belleo, you probably know him from Scientific Institute. So they looked at, you studied people's behavior with Wikipedia, so they studied pages. And what they found were like pages like the Palestine one, right? So that's, you have two sides with like clear views. And you can see the history of the people who were editing it and how they're editing it. And they found that they had reached some sort of a consensus by themselves. Or if you go back in history, they were fighting each other and editing the page got logged. So that's an interesting study, might be of interest.
So we started off talking there about the what, and then moving on, the curiosity is more about the how. And when you talked about the networks, I quite liked your example of linear algebra and the kind of smaller networks, and reminding myself, and I enjoyed studying like linear algebra, but also I was curious about learning about culture, so I hopped on a plane and to Saudi Arabia and see what happened. So is there actually space for the why as well? So not just the how, it's a combination of the how and the why.
Yeah.
Or maybe that's the answer, that it's actually a bit of both.
That's a good question, yeah. Right now the why is not necessarily in there, but we can certainly see, I don't know the degree to which I can release the information, but we can see based on the period of time in which people were browsing, so the period of time over which the study was occurring, there was something very clear that happened in American culture and British culture that certainly seems to have impacted a few individuals in what they chose to be reading about. And that's something that we infer just from the temporal correlation between the two. It's not something that we explicitly ask people, why are you going to these pages? But that's interesting because I think in the second round of this study, we're hoping as people move to the new page, we're asking them, why are you going to this new page? And particularly we want to know whether it's out of boredom or not out of boredom, because searching for very new and different information or connecting two ideas that are fairly dissimilar from one another could be simply from boredom, or could be that you see analogies between very disparate things. And those are very different features of mind, and we would like to be able to distinguish between the two. So that's something that will be in set 2 experiment 2.
The lady in front.
I'm just wondering if you ever looked at the interplay between mindset and curiosity, or what type of network structures emerge. So I guess for a fixed and growth mindset, that's a way of thinking and learning. And I'm just wondering if someone with a fixed mindset, what type of knowledge networks they would have in comparison to someone with a growth mindset. Just because that's about learning and curiosity is about learning. I was just curious.
Yes. Yeah, absolutely. I think we did not examine that in this particular study, but I do think that that's probably an important factor here as well. And even the access of the individuals to knowing what a growth mindset is, which brings in interesting socioeconomic considerations of socioeconomic status and what kinds of information are children being given about the sorts of curiosity they could have, and what kind of information are they not being given, and why. So yes, that's a direction that we're very excited to go in as well.
The gentleman at the back.
If I got it right, seems to be predominantly an examination of curiosity as a means towards information. or knowledge. I'm just wondering if there was any emphasis or focus particularly on the state of being in curiosity, physically, emotionally, mentally, and otherwise.
So I guess the only part of the study that to some degree gets to that is looking at the same individual over the 21 days and asking whether they're building the same kinds of networks or browsing in the same ways over the 21 days, or if they change from day to day, which would suggest that it's much more of a state characteristic than a trait characteristic. And we do see some amount of temporal variation from day to day, although there is also, basically you can divide every person into a trait component. We all have a tendency to browse in some sort of architecture, but then we also have fluctuations from day to day. Understanding what's driving those fluctuations is a very interesting question. And is there, particularly when we're thinking about young kids, is there a way of encouraging certain states that would then lead to certain kinds of curiosity is an interesting question. So I do think that there are state components and trait components, at least in our data, and I would imagine in children as well. I should say these are all adults.
Lady in front.
I just wondered if you did any research on outcome in relation to curiosity. So by following your curiosity, for example, you have a specific outcome and that maybe encourages you to continue along that path. And if it has, if following your curiosity actually does help someone to actually realize the objective that they had in the first instance, or if that kind of curiosity is fueling such, growth in scientific research and all that type of stuff. I just wondered in terms of outcomes.
We didn't have specific outcomes in this study, but I do agree that that would be important. I also think that that links directly to questions about environment, because in certain high-risk environments, curiosity may not lead to good outcomes. Curiosity in life experiences, for example, in a risky or unsafe environment could be bad. And so I do think that an interesting question, along with questions of socioeconomic status, are questions of environment and the safety or lack of safety in your environment, and how that could play into your choices in curiosity, not just in life experiences, but also in the way that you search for information. And so that's something that I think is an extremely important question, and something that we need to be addressing as well.
Hey, thank you for your talk. I'd like to ask whether you notice common characteristics in the sort of people who are busybodies or hunters. Like in terms of such as age or demographic information.
Yeah, there is, I think it's a little bit too preliminary to talk about now, but we do collect some additional information about age and mental health status, for example, that I think there are some interesting predictors preliminarily there, but I think, I'm going to wait until it's a little farther along to describe.
And just to double down on that, you're not saying that one individual remains in a certain state forever.
No.
They obviously expand.
They change.
Yeah. The gentleman in the corner.
Data, information, knowledge, and wisdom, I think, have been compared by a lot of people. Some of them by T.S. Eliot, and some have you come across Mike Cooley, who wrote a book called Architect for B. Anyway, I'm just wondering, they've expressed concern about the relative abundance of these and the fact that we live in a society where the amount of data is absolutely vast. I'm wondering about the amount of wisdom. So is there any work on relative abundance of data, information, knowledge, and wisdom?
That's a great question, and not one that I have the expertise really to answer properly. I think it's interesting though, because there is a similar conversation that is happening in the sciences, which is that we are currently being flooded with data in healthcare, for example. And it's, to some degree, it's unclear, is all of that data really helping us, or is it just adding noise to the picture that we have? And so I think it's hard to know, is it adding noise, or eventually will we be able to understand the principles behind that data, and then yes, it's adding knowledge and wisdom. We don't know yet because we aren't there, so it's it's a quandary. When you start, particularly when you're thinking about humans, there's a limited time period in which to acquire the information in a healthcare situation, and so you need to decide what pieces of information to acquire, what pieces of data to acquire, right? And so you don't know, should I keep collecting this piece of data because I think it may be useful in the future, or should I cut it out of the study because it's not clear yet how it fits into the model, right? So that's something that I think scientists are constantly facing, but it's even more pressing now with the capacity to acquire and store more data over short periods of time.
If you just sort of take that question from a network perspective, so there has been this idea in Robin Dunbar and all these people who work on it that you have a limited size network and you can sort of manage the signal to noise ratio because of the brain and all that sort of stuff. But now with this idea of infinitely scalable networks, we are faced with this problem of misinformation, we call it fake news. Even in academic journals, peer-reviewed journals, a lot of studies are not passing the replicability test. So is there this idea of infinite scalability? How achievable is that, or is there a cognitive ceiling to a network like Dunbar suggests?
I don't think it's infinite, but that's just my opinion. But maybe I can also I push back a teeny bit, or maybe not push back, but add my perspective on the lack of reproducibility of scientific claims sometimes. And I think it's just important to know that science continually evolves by having people express a suggestion, postulate something, describe a theory, and then have it be invalidated, and then we move on. That's information that we gain for something new. And so I think I see some of that as just the process of science. And so I do understand that it's also important that we move towards reliable and reproducible results that will be included in our theories. But I think science will always have parts of it that are where we're trying to figure out the answer.
Correct.
Every little bit is important to publish.
That is a scientific method falsification. They're in psychiatry, probably know there's a lot of body stuff going on. All right, you.
I just wanted to ask, why the 21 days you've chosen for the length of doing? Is there something behind specifically 21 days particularly?
Yeah, so that was to some degree determined by David as a trade-off between the length of time that we're able to get full compliance from the participants, so people can stick it out for 21 days. And he's done many of these studies, and he tries to push it as far as he can while maintaining full compliance of all individuals. If you go a little bit farther, then we start losing people. If you go a little bit fewer, I think there are several people who could have gone longer. So there's some work in the literature just suggesting that that's a reasonable time period over which people are willing to commit to this daily examination.
Thanks very much for the talk. I don't know if it was covered by somebody else who said, but I just want to put it down as a concept of the psychology to nature versus nurture. So of these individuals, is it their level of curiosity where they go into, controversial is body, predetermined by their level of education and knowledge taught them, or by the level of experience they've learned through their experience knowledge?
Yeah.
And does that affect, is there any thought in relation to that?
That's a great question. We did not determine whether or not any of the participants were siblings of one another or twins of one another, but that would be the exact kind of study you would need to address your question, which would be super interesting. We haven't done it yet.
Because it's very, very important in the terms of from neural networks for artificial intelligence, how much determined learning models you give will have how you build a network. So I was wondering, does that apply to this opinion?
That's a great question. Yeah. I would love to know the answer.
I think you had a question.
Firstly, Danielle, thank you very much. I think the fact that this room is packed is kind of an attack, probably with curious people given your topic. It's a good starting point. But when you talk about science of the mind must account for the minds of today and of yesteryear, I would add to what you're saying and give it a lot more import, because I think it accounts for the minds of today and yesteryear, but also the technologies of today and yesteryear. And the technology shift that's happening is exponential. And we won't go talk about AI and all because the world's falling apart in singularity. But I do think that the type of work you're doing can act as an antidote to the echo chambers that are being created by the technologies of today, to the Cambridge Analyticas, to the people having the same mindset from a fake news perspective, and would encourage you to look at what can be done from an education perspective to embed curiosity. Like your comment at the beginning of your talk was a joy, to be honest, which is the joy of raised hands in the classroom. If we can do something to get back to the joy of raised hands in the classroom, not at an individual level, but at an educational level, and figure out how to continue to grow that as we become adults, I think there's a huge opportunity to figure out how to influence in that area, and would encourage you to think about it at that level. What do you think?
Thank you. So we'll take 3 more questions. Please keep the questions succinct and short. Stop.
Thank you so much for the talk. One of the questions you talked about NLP, natural language processing, and you talked about looking at sciences and philosophy of yesteryear, so maybe Enlightenment era and philosophers from that period. Would there be any chance of being a bit biased, gender biased, if you think about scientists from or philosophers from that time?
Yeah. Yes, I think that there's absolutely and we need to distinguish between the bias that occurred then at that time period, which meant that there was only a certain percentage of certain genders in the position, and gender bias now of not listening to the more diverse voices who did exist then, even though there were few, right? And so yes, there will be bias that had existed then that we can't do anything about. But obviously we need to, when we do go back, we need to be sure that we're canvassing as broadly as possible. So I'm actually working in a collaboration right now where we're trying to address some scientifically, so quantify and then address pretty systemic bias in citation practices in our fields. And so I think that that's something that would be very obviously important to take into the area of philosophy as well.
The lady at the back.
Hi, I was wondering if you did any study on levels of curiosity in people with dementia. The participants we took over the 21 days, did anybody have dementia?
We did not do a full clinical assessment to know whether they had dementia or not. So that's something that we did not include in the study. However, I think it would be very interesting to and we're moving immediately down into lower age ranges, so to adolescents and children, to examine the kinds of curiosity and compare them to the browsing patterns of the adults. But then I think the next step would be to go to older age ranges specifically, and then have a more full clinical workup, so collaborate with a neurologist who would be able to evaluate them. So I think that would be quite interesting. It's not something that we evaluated in this study due to lack of resources.
One of your slides briefly mentioned non-humans, and then often our sort of treatment like human sort of domination over non-human animals is sort of framed by painting them as sort of like mindless automatons. And has your study, or have you come across any other studies that sort of finds any of these curiosity network building patterns in non-human animals as well as humans?
That's interesting. Yeah, I meant non-human as in artificial intelligence. I haven't even thought about other non-human animals. That's a great point. It actually reminds me of the fact that Perry Zern is developing right now a sort of quotations from the past that have described curiosity by animals. So there are some amazing connections with cats, with frogs, with butterflies, with, there's a whole octopi actually. And so there's just a whole description of how each of these animals reflects in perhaps their movements or in their other feeding practices or otherwise different kinds of curiosity. So I think that's a really interesting point from the humanities side. From the science side, there is certainly a lot of work in trying to understand curiosity in monkeys, and there is some work in other animals as well, but not these particular notions.
Yeah, there's in this and this is not the UK, so this is Ireland. In the UK, the Planck Institute, sorry, it's been a very long day. They did this study where they released captive birds who spent all their lives in captivity, and they taught them a certain trick, which birds in the wild did not know. And then when they released them, they learned over time that even wild birds were acting like that. So there was some transfer of knowledge and learning, and that couldn't have happened if those wild birds, I mean, that's a hypothesis, weren't curious, because they'd been doing something for a very long time and they just changed their sort of actions. But no, I think, you want to take one more? Or? Okay, we'll take one more. Or you've already asked.
It's a quick one.
Okay.
I saw the end of the Joyce quote. I think it was about the selection of words, or no one already, it's how you place them and so on and so forth.
Yeah.
Did you look at Alice in Wonderland? I just wondered.
We haven't looked at Alice in Wonderland. We have been studying textbooks to understand architecture and how information is presented in an ordered fashion. But we haven't done Alice in Wonderland. That would be great.
Thank you. Thank you, Professor.
Quick plug before we finish up. So the last talk of the series will take place in September. A love letter to realism in a time of grief will be delivered by explorer Mark Pollock and human rights lawyer Simone George. And we're thrilled that Ian Robertson here from Trinity, neuroscientist and clinical psychologist, will follow this talk with an interview with both speakers. Tickets are now available online through the Trinity Long Room Hub website, and we hope many of you will join us. So with that, just thanks again both to Syed and to Professor Bassett for joining us all the way from the States to be here tonight, so we really appreciate that. And join me again.